Good afternoon, sir. Shall we start now? Guys, I need some response. Is it visible, ma? So I'm going to handle your database management system. So here we are going to look forward the titles like ER model, relational algebra, tuple calculus, SQL, integrity constraints, normal forms, file organizations, and indexing. Especially we are going to learn about B and B plus tricks, transaction and concurrency control. Okay. So I'll start with the basics first of all. So like introduction regarding a databases and what are the models available. Then we'll move on to your ER model, relational model, algebra, tuple calculus, etc. I think you all learned about already in the third year. I think so. Yes. So what is my database first of all? Database management system. Anyone? What is database management system? Just have an overview. Anyone? Prepare करनी with the topic one. So since we'll be given to start with an ER model, we are going to start with the database management system. Here definitions and then applications, then we'll move on to types of models here. Okay. So database management system is nothing but a collection of interrelated data. Like we'll split it up. As database in the sense data in the sense it is a raw data. Database in the sense anyway we are going to have a collection of raw data in a like not in a prescribed format. And management in the sense we need to take it in any one of your model to rearrange all your data, like all your raw databases, and then systematic in the sense we are going to convert into a perceptual view. So this is how we are going to learn about the database management systems. So it is a collection of interrelated data and having a set of programs to access those data. So whatever the data we are going to store it in the databases, like a centralized databases, we need to have some set of programs, or else we need to have a query format to access those data. Okay. So this database contains information about a particular enterprises. For example, if I'm taking a student databases, so the centralized server will hold the complete databases regarding a student, not only his academics oriented, but also his personal perspectives also. So whatever the data we need to get in user point of view, we need to access those centralized data with the help of any either programs or with the help of a query format. Okay, so these database systems are designed to manage a large bodies of information, and then it ensures the safety of the information stored. And again, once we'll be having a centralized databases, we need to have a safety measures there to be constrained. So that is also to be maintained here in terms of a database management system. So moving to your applications, we can apply all these database applications in terms of bank, airlines, universities, sales, manufacturing, human resources, etc. Now, why we go for a database system rather than a file system in the sense? So, file in the sense we need to have we don't have a systematic view, right? So we'll have only a manual clerical works will be there, clerical values. And one more example, if you want to change a particular database, for example, if you want to change the name of a person in one particular thing, so what I have to do, it has to be reflected back in all the files wherever we are maintaining as a manual relation, right? So that becomes a more complications in terms of file system. So drawbacks of using file system to store the data is one in terms of data redundancy and inconsistency. This shows that when I'm having multiple number of file formats, once I'll be changing a name in one particular page, that should be replicated or reflected there in each and every other formats wherever it gets the particular student name or particular person name gets saved. Yeah. So that I couldn't find the redundancy and an inconsistency. Inconsistent since it duplicate information in different number of files. So this can't be avoided in terms of file processing system. And again, difficult in accessing a data. And again, need to write a new program to carry out each and new task. Nothing but if I'm having more number of data in the file processing system, and again, if you want to access the data, again, I'm going to create a new program. Whereas in terms of a database management system, we need to have a query, or else we'll have set up predefined programs or library files. With the help of that, we can able to access the data. And then data isolations, multiple files and formats. Since we do have a multiple number of files and formats, data gets isolated then and then, but it should not be. It should be redundant. It should be in consistent way, right? So that again leads to another drawbacks in a file processing system. And one main thing is integrity constraints. For example, if I'm taking RDBMS like relational model, there I can able to apply a primary care, foreign care, whatever may be the constraints, I can able to code it right. Whereas in terms of file system, it is not possible at all. So these are some of the reasons why we go for a database management system. Okay. Now moving to your types of models. So, what are the types of data models we have? In the sense, we have entity relationship model, relational model, and then apart from these two models, we are going to learn about a object-oriented model, object relational model, semi-structured data model, network and hierarchical model. These are some of the models we are going to learn it in the general data models. But here, the portions will be covering only to your ER model, relational model, and then we'll be moving to your typical calculus and SQL thing along with your integrity constraints. So I'll move on to an entity relationship model now. So you know that entity like relational algebra உங்களுக்கு வந்துட்டு you'll have your some terminologies, right? Here, what is meant by tuple, what is meant by record, what is meant by file, everything, what is meant by attribute, etc. Right? We will move on to some basic terminologies in an ER model first of all. Then I'll move on to entity relationship model. So here we are going to learn about basic terminologies, what is meant by entity and what are the attributes and how you are going to represent all those terminologies, right? So here an entity almost know that it is a real world object, either it can be anime and inanimate that can be easily identifiable. So entity of being it is it is a set of, it may be a name or it may be a person, whatever it may be, right? What are the attributes we'll be having? Entities are represented by means of a properties called attributes. So these attributes will have some values. Okay, for example, when I'm naming a student as an entity, you'll be having your attributes like name, class, age, etc. And each and every these attributes will hold some values. Okay, ma'am. And in terms of an attributes, we do have some types. One in terms of simple attribute, composite attribute, derived, single valued, and multi-valued attributes. So each and every all these cases will have some sort of representations, like in terms of an ER diagram. Okay, we'll see later on. Before to that, I'm going to have a terminology alone. So simple attribute. What is in the simple attribute? It is an atomic value which cannot be divided further. For example, if I'm taking an student phone number, definitely it should be an atomic value of 26, right? So, and again age. So age cannot be subdivided further. So see, these are some of your examples of the simple attributes. Nothing but it is an atomic value which cannot be divided further. Okay. So whereas composite attribute, these are made up of more than one simple attribute. For example, when I'm taking a name of a person, he may have his first name, middle name, and last name, right? So in that case, if a particular attribute can be further divided into further things, then it is said to be a composite attribute. Okay. Then derived attributes is nothing but they do not exist in the physical database, but their values are derived from the other attributes. For example, when I'm saying an date of birth. Suppose when I'm asking you to specify a date of birth, I can able to calculate your age, right? So this can be said to be, these are some of the examples of a derived attribute. And coming to a single value attribute, so this contains a single value, and I mean that it should not have a multi value redundancy. It should not have a redundancy. Okay, ma'am. So for example, register number. So it should be an atomic and unique number to a single person. That is another example of a single value attribute. And multi-value attribute in this is it contains more than one values. For example, a person can have more than one phone number or more than one email addresses. For example, all these comes under a multi-valued attributes. Okay, so these are some of your types of attributes. One in terms of simple, composite, derived, single valued, and multi-valued. So finally, I should place your representations now. And coming to your entity sets and keys. So key is an attribute or collection of attributes that uniquely identifies an entity among entities. For example, if I'm specifying a particular like particular attribute as a super key or candidate key, or it may be a primary key, it should be represented in ER model in an easiest way. Okay. So when I'm saying that a particular key is a primary key, it is one of the candidate key chosen by the database designer. Hold for a second, pa. And regarding your key, we'll have your super key, candidate key, and then primary key. So this is regarding your integrity constraints. So in terms of a primary key, when I'm choosing an attribute as a primary key, it should be unique and it should uniquely identified entity. It should be an uniquely identified entity and should have a unique values and atomic values. Okay, well. And coming to relationships, so relationship and relationships set can be like a relationship can be done in the one to one, one to many to one, and many to many. We'll have four types of relationships. So based upon that, we'll based upon the ER databases relationship, we can able to apply these cases. Okay, wow. Now, so this is regarding your mapping cardinalities. So the mapping can be done in four cases. So either one to one or one to many and many to many to many. Okay, I'll showcase the example for a ER model now. Representations of each and every entities. So when I'm saying that entity, it should be represented in this way, like it should be in a square rectangle box. So entity is nothing but it means that n name of a person or it may be a thing. Okay, an attribute. So attribute had different four types of attributes. One in terms of simple attribute, it should not be further subdivided, and composites in the sense it can be able to further subdivide it into further parts. For example, name. It may be first name, last name, other name. Okay. So this is again a general attribute. Like when I'm specifying a student, that should be an entity, and name, birth date, roll number will be becomes a normal attributes. Say suppose if I'm having a composite attribute, for example, if a particular name should have a first name and last name, then it should be represented in this case in a composite attribute in this way. And moving to multi-valued attributes, multi-valued in the sense each and everything should have more number of like not only a single value, it can have more number of values. For example, when I'm taking a student entity, so there I'm having an attributes of name, birth date, roll number, and phone number. Here, a phone number can have more number of phone numbers, right? So that can be represented in double circle. That shows it is a multi-valued attribute. And derived attribute, I can say that from a particular attribute, I can able to derive another value, right? For example, when I'm specifying in date of birth, or else when I'm specifying in age, when I'm asking you to provide a birth date, I can able to derive an age from that, right? So this is it to be in derived attributes. Now coming to a relationship. So relationship can again I had said that it should be an either it should be binary or ternary or more than that, right? So it is a one-to-one relationship. For example, if I'm specifying one, then that should be a relationship between this particular entity. Like one for those two entities, the relationship remains as in one, right? So when I'm having 1 to n in the sense, it should be represented in this way. We do have two entities. So in one to n relationship, this is an n to one relationship, this is an n to n relationship. Okay. For example, if I'm specifying your constraints and the participations, either it may be total participation or it may be partial participation. If I'm specifying a double line between a relationship, like that says that this particular entity will be having a total participations over this relationship, whereas when I'm specifying a single line, that shows a partial participation. Okay, so this is how we do have here ER models. Like in this basic terminologies as well as diagrammatic representations, we'll go with an ER diagrammatic model. For example, student databases, or it may be an internet banking system, or an employee models. So all those cases will have here these relationships. Okay, so whenever I will be given a question to derive an ER model, what are going to do? We are going to first of all analyze the entities, like what are the entities we do have and what are the attributes. And attributes we do have four types. Adula enna attributes la vandu edu multi valued irukkalam, edu composite irukkalam. So we have to analyze each and every categorizations, and then we'll go for a diagrammatic representation. Okay, ma'am. So this is up to an ER model. Now I'll move on to your second one, relational model.
Yes, sir.
In a relational model, we are going to learn about relational algebra, typical calculus, as well as SQL integrity constraints. Okay, so today we are going to see up to your normal forms, then we'll move on to your next three topics in the next class. Okay, now moving to your relational algebra. So in terms of relational algebra, so this is a procedural query language. So relational algebra, in essence, it is a procedural query language which takes instances of relations as inputs and yields an instance of relationships as output. Okay. So what I'm going to do here is, again, it is in the formation of a query, but what happened here is in use here like operators in the sense either it can be an in-array operator or it may be a binary operator. So what are the operations we do take under a relational algebra data? First one is select, project, union, set difference, Cartesian product, and rename. Okay, so these are some of your operations in terms of a relational algebra. Like each and every all these operations will take your will consider either a unary operator or a binary operator. Okay, depends upon that. If I'm saying an unary operator like union, that comes under a binary, and set differences will operate in an unary operator also. Okay, ma'am. So we'll start with the select. So operation, first of all, it should be represented with a symbol like sigma symbol. So what this will do அப்படின்னா when a sigma stands for a selection predicate and r stands for a relationship, then how we can able to represent this one அப்படின்னா like select the subject which is equal to databases from the table name books. So this is again an example. Just look down this one. So select the tuples from book where subject is databases. This is a meaning. So usually நம்ம வந்து query ல என்ன பண்ணுவோம், by using a data query languages we can select star from so and so book where some conditions நம்ம கொடுத்திருப்போம் இல்லையா. But here I'm specifying a relational algebra பொறுத்த வரைக்கும் select, you can say that we'll use a symbol sigma, and then what I'm going to do like in the conditions. So select கீழே நம்ம என்ன பண்ணணும்னா we should specify the condition here, subject equal to. So here I should select the subject where the name will be having a databases, right? So the condition should be here subject equal to databases, and here I'm going to specify the title of table, like table title, that is again books. Okay, ma. So simply we can say, we can write it in a query format like select tuples from books where subject is databases. So nothing but this is again a predicate. We can say this simply equal to a data query languages alone. Okay, only the thing is we're going to represent with the help of your symbols here. Okay, ma'am. Now, coming to a second one, like project operations. So second operation is a project. So project in the sense, it'll have your nominations. It'll have your symbols in this pi symbol. So where when I'm specifying pi, A1, A2 up to AN and R here in the sense A1, A2, AN அப்படிங்கிறது எல்லாமே attribute names இருக்கும். And then here R represents your relationship. For example, uh, uh, if- so if you want to predicate or if you want to project uh, a particular field alone, so what I'm going to do, we are going to specify it in terms of here project operation. For example, usually நம்ம என்ன சொல்லுவோம்னா ஒரு particular ரெண்டு attributes மட்டும் select பண்ணலாம், like select name comma register number from so and so table அப்படின்னு சொல்லும் போது we will be pinpointing some attributes, right? So in that category we will move on to a project operation, select subject comma author from books. So there is no need to specify some conditions. Just I want to pinpoint some attributes. We are not going to specify all the attributes to get displayed here. So only the thing is I need to display only a limited, or else only pinpointed attributes alone. In that case I'll go on to a project operations. Okay, now moving to the third one is union. Union and set difference. This is similar to our normal operations. Union in the sense we are going to add those tables which is represented in both relationships like R and S. Okay, ma'am. So here, this is in the general notations of R union S, where R and S will be an either database relationship or may be a relationship, and then union representations will be an union of all. So this is a union operations where I'm going to specify RNAs as their relationship, and union represents this will add all those tuples which is available in both the relationship. For example, when I'm specifying select author from books, union select author from articles. So in this case, I'm going to specify two table name books and articles. So here I'm going to have an union operation, mean that I'm going to club all those author names, which is even though it gets replicated, all those category gets reflected here. Okay, wow. And set differences. Coming to the next operation is a set differences. So here, when I'm specifying R minuses, this is the notations of your set differences. This are you listening? Yes. Any reply from your side, ma'am? At least in a message. Simply logging in. No response. Yeah, I'm going to continue this. So set differences in the sense I'm going to have your notation as R minuses, mean that R and S will be your relations. And here, when I'm specifying a set differences, which represents that one that display the results which is present in one relation but are not in the second one. So okay, well, so this how we are going to get the results here in the sense when I'm specifying two relations R and S. So what happened here is I'll take the same example. Select author from your books and then select author from articles. I'm going to take only the display of author books which is present here, and if not, it'll just compare with the next one of your articles with an author represented here. If I'm having a common name, that alone get displayed here. Okay, one. And Cartesian product, again, it is a two different relationships into one. This is representations of R into S. So here, select author equal to tutorials point where book into article. I'm going to combine these two tables, and then I'm going to select only the author which is having name equal to tutorials point. In that case, that alone gets displayed here. Okay, ma. And rename operations nothing but just I'm going to replace the name of a table or a relationship already existing. So here when I'm representing row, this is a symbol of row. So x and power e in the sense here what happened, the result of expression e is saved with the name of x. So instead of e, the relationship that gets saved in terms of an x. That's it. Okay, so this is up to your relational algebra. Here we'll be having some set of operations, both in it will be applying both in terms of unary as well as binary. So we'll be having select, project, union, set difference, Cartesian product, and rename. Okay, so now I'll move on to your next one, tuple calculus. So I think this we had seen now. Moving to an SQL now, SQL along with an integrity constraint, and I'll wind up with the normal forms. Okay, I'll take the SQL. So you all know about an SQL command like structured query languages, right? So in terms of a structured query language, why we go for this query languages in the sense, in order to access the databases, like access the databases, we need to have some set of communications. Like we'll go with the query languages as far as DBMS is concerned. So like it's RDBMS is concerned. So we'll have some several types of commands you all know about already: DDL, DML, DCL, TCL, and DQL. Like data definition, data manipulation, data constraints, and then transaction query language and data query languages. Okay. So this is up to one SQL commands. We'll see one by one, like the basics, how we are going to utilize in a syntax, and what are the examples. Okay. And like you all know about SQL commands, these are some of your instructions. It is used to communicate with the databases and also used to perform specific tasks, functions, and queries of data. Okay, ma'am. So what are the operations we can able to perform with the help of an SQL? Like query language instance, we can able to create a table, we can able to modify the table. Like in terms of a skeleton, I can able to modify or alter. And once the values get inserted, I can able to do your delete, update, etc. Okay, ma'am. These are some of the operations I can able to perform with the help of your database systems. Okay. Now coming to your types of SQL commands. In general, this can be divided into 5 categorizations. One is a DDL, DML, DCL, TCL, and DQL. So in terms of a DDL, we are going to learn about create, drop, alter, and truncate. As the name indicates, data definition language, we are going to able to form a skeleton. We are not in calculating with the values. We will be operating only with the skeleton. Like we can able to create a template, or we can able to create a skeletal view of a table with the help of a create command, and drop in the sense if you want to drop a particular column or it may be a particular table, again we can do with the help of a drop syntax. And alter in the sense we can able to modify the column name or column width, whatever it may, but everything can be done before inserting a particular value. That is, everything can be done only with the help of a skeletal means skeleton point of view. Okay, and truncate in the sense we can able to drop the tables, so either permanently or temporarily. Okay, and coming to DML, we will be having three set of commands: insert, update, and delete. And that operating with the help of a manipulation. And DCL in the sense we will be having here constraints like grant and revoke. So either we can able to grant, in the sense we can able to provide some permissions, and then or else we can able to get revoked back. And TCL in the sense we'll have your transactions control languages, nothing but while doing some operations in a databases, we do have to save, right? So that can be done with the help of a transactions control, like in terms of a commit, rollback, and save point. DQL, we all know about it. There's a query language. We'll be applying a select mode. Now we'll see the syntax as well as here examples. Okay. Now coming to data definition language. So DDL changes the structure of a table, like creating a table, deleting a table, and altering a table, etc. All the commands of a DDL are auto committed, and that means it permanently save all the changes in the database. So we are not specifically doing a commit statement here. Instead, it will be automatically get saved. Once I'm doing a particular changes, or once I'm creating a new table, it gets permanent saved by defaultly. Okay. So some of the commands we are going to learn in a DDL is create, alter, drop, and truncate. So what is the syntax for a create in the sense? Create table name, and then we are going to specify a column name along with the data type, etc. Okay, ma'am. For example, if you want to create a table of employee, create table employee and name. Within that bracket, we are going to specify the name of attribute, and then along with the column like data types. Okay, ma'am. For example, employee table, and will be having name as an attribute and email as another attribute, and name will be in a varchar and email also in a varchar. Okay, and date of birth in the sense it is in a date format. Okay, and moving to a second command of using a DDL as a drop, it is used to delete both structure as well as the record stored in the table. Okay, so if you want to delete a particular record, or else if you want to drop, or if you want to delete the complete table, I will be moving to a drop command. So drop table name. Okay. So moving to the next third command is an alter command. So as I have said earlier, alter is used to modify the skeleton view. For example, if you want to add a column or modify a column, I can do perform with the help of an alter command. So in order to add a new column, I have to use then alter table name add column. So we will be using a keyword of add here. That indicates that I'm going to add a new column to the existing table. But this can be done with the help of a like alter table, right? So with the skeletal view. Okay. So again, if you want to add a new column name, and then that should be a definition. Definition this is like the databases. Okay. If you want to modify the existing one, suppose if you want to add a new one, then I'll be using a keyword of add. And if you want to modify the existing one, then I can able to specify the modify command like alter table name, and I'm going to apply and modify. Okay. So this is again an example. Alter table name. Add. I'm going to add an address with the data type of varchar. And second example indicates that so since we had created already, if you want to modify the existing attribute, for example name, I'm going to specify that alter table name like stu underscore details and modify that same. It should not be reflected. So you have to take the same name, and it can able to change the data type, either it be varchar 20 or 40, whatever it may be. So this is up to an alter command. And the last one in the DDL is a truncate. It is used to delete all the rows from the table and free the space containing a table. So truncate in the sense I'm going to delete the entire rows, and the memory space occupied by this particular table can be revoked back, like can be reused back. So truncate table name. So this is your truncate DDL commands. Okay. Now moving to a second one. So we had looked back so far DDL, create, drop, alter, and truncate. Now moving to your DML, insert, update, and delete. So Moving the data, as the name indicates, data manipulation. So data manipulation, this is we can able to insert some values like modify the databases. So we can apply any sort of changes here. For example, if you want to do your insertion, or if I want to do an updations of a particular table or a particular record or a particular column, and if you want to delete a record or delete an entire table, I can perform with the help of data manipulations. Okay, ma? So here, what's the difference between DDL and DML in the sense? DDL in the sense it is a skeletal view, like skeleton representations. Right? We can able to create a skeleton view of a particular table, whereas the manipulations like insertion deletions can be done with the help of a DML commands. And another main difference is once I'll be creating an so in terms of a DDL command, DDL will be auto committed. Like once I will be creating a table or once I'll be modifying or altering the complete skeleton, it gets saved automatically. Whereas a DML command, it is not auto committed. We need to perform a constraints like transaction constraint. We need to perform a commit statement. Then only the changes has to be saved. Okay, ma. So some of the commands used in a DML is insert, update, and delete. So commit and insert statement will be having a syntax as insert into table name, and then we are going to specify a column, and then followed by a values as a keyword and followed by values. So here the main case here is it should be replicated as such in a create table. Okay, once I'll be creating a table அப்படின்னா அந்த column name insert பண்ணும்போதும் கரெக்டா ரிஃப்ளெக்ட் ஆகணும். mismatch ஆச்சு அப்படின்னா values insert ஆகாது. Okay, and then another way of inserting a value is insert into table name values, and then directly we can able to specify the values without skipping any column. Okay, ஒரு எந்த attributes மிஸ் பண்ணக்கூடாது. If I'm specifying a table with 4 number of attributes, that 4 attributes must have the values here. Instead, if at all I'm not using any constraints there. Okay, so if you're not using constraint, definitely all attributes must have the values during an insertion executions. Okay, now coming to the update. So this command is used to update or modify the value of a column in a table. In order to update a particular column or a particular field, we can able to use your update command. For example, update student set username equal to some name where the student ID will be this so and so. Like if I want to update like a particular name or whatever it may be an attribute, so there I'm going to use a keyword of set, and then I have to specify which attribute, like which field should have this particular value, and then based upon the conditions. In the conditions like in the particular field இதை change பண்ணணும் அப்படிங்கிற பாயிண்ட் ஆஃப் வியூல நம்ம கமெண்ட்ஸ் இருக்கு. ஓகேவா? And moving to the third one, delete it is used to remove one or more row from a table. So delete from table name where some conditions. Okay, so I'm going to specify, for example, if I'm going to delete a particular record alone, so I'm going to specify the conditions like delete from so and so table name where the condition equal to, like, so in the condition, suppose if I have more number of tables with the same name, like render rows the same author equal to so no render row those 2 rows gets deleted here. Since I didn't specify a unique value here, so I'm going to specify only the author name. If suppose if I'm having more number of 2 rows with the same name, so those 2 rows gets deleted here. Okay, so this is a clear DML commands. So DML insert, update, and delete. Now moving to a DCL command. So DCL, as I said, that it is applicable for constraint giving, like permissions grant, permissions if a particular user க்கு நம்ம என்னெல்லாம் provisions கொடுக்க போறோம், எதை நம்ம work பண்ண போறோம் அப்படிங்கிறது மட்டும் DCL இருக்கு. ஓகேவா? So moving to a DCL, data control language, it is used to grant and take back the authority from any databases user. We have only 2 commands here, grant and revoke. So grant is used to give user access privileges to databases, whereas revoke is used to take back the permissions from the user. And then coming to TCL, so transaction control languages in the sense. TCL commands can only use with the DML commands like insert, delete, and update only. So, but TCL commands in some way it is again a transaction control language. So, only the case we can perform a manipulation is done with the help of a DML commands alone. So, DML commands are insert, delete, and update. So, only these TCL commands can be applicable only for the DML commands alone. Okay, so what are the transaction command control languages or commands we do have here is commit, rollback, and save point. So as I had said that DDL can be auto saved, whereas DML commands cannot be auto saved. It had to be uh, specifically given some commands for saving and rollbacking, like get backing. Yeah, so for, in order to save that, we will go for a commit, rollback, and save point. We'll go see an example. So commit in the sense, commit command is used to save all the transactions to the databases. So for example, like whatever the data, whatever the table I had inserted, whatever the rows I had inserted in a particular table, say suppose when I'm creating a student table and I inserted 5 rows. So after inserting a 5 rows, I'm giving a commit statement. What happened here is all those 5 states will permanently saved. Okay, ma'am. For example, when I'm performing in operations, not only in insertions, but so it depends upon these three actions like DML commands, insert, delete, and update, right? So here I'm doing a deletion operations, delete from customer where age equal to 25. So after deleting this particular record, when I'm specifying commit statement followed by this statement, automatically these changes get saved permanently. Okay, ma'am. So this is a print commit statement. Now coming to rollback. Rollback command is used to undo transactions that have not already been saved to the databases. So when I'm specifying a rollback, the last transactions, like this is similar to a control is it an undo statement. So when I'm so the last statement I had done is a delete from customer by age equal to 25, right? There I had performed the commit statement for saving those actions. Now when I'm giving back again rollback, what happened here is that row gets revoked back again back to the table. Okay, this is the rollback. And save point in the sense it is used to roll the transactions back to a certain point without rolling back the entire transaction. So when I'm doing some insertion operations continuously and deletion operations continuously, and in between when I'm specifying a save point name, like save point is a keyword, save point underscore name will be a name. So what happened here is it shouldn't we were it avoids an unnecessary rolling back of an entire transaction. Like எந்த பர்டிகுலர் பாயிண்ட்ல இருந்து எனக்கு ரிவர்ஸ் சேவ் பாயிண்ட் ஆகணும் அப்படிங்கிறது இப்போ சப்போஸ் இன்செக்ஷன்ஸ் பண்ணிட்டு எனக்கு அந்த ஒரு நேம் கொடுக்குறேன் டெலிஷன் ஆப்ரேஷன் பர்ஃபார்ம் பண்ணிட்டு ஐ ஹேட் கிவிங் சம் சேவ் பாயிண்ட் அப்படின்னா ஸோ நான் எந்த இடத்துக்கு ரோல் பேக் ஆகணும் அப்படிங்கிறது if I'm specifying the save point and some name abdina, I can able to get back to those locations directly. Okay, not instead of rolling the complete entire transaction. This is a real save point. So these are your transaction commands. Like we will have your commit, rollback, and then moving to your save point. Okay. Now coming to the last one, a data query language. So data query language will be having only a select as a command. So it is used to fetch the data from the databases. So this is one and only query language will be having. In order to access the database from the centralized server, we'll have a select command. So it is again select being it is similar to project. நம்ம இந்த regular relational algebra உங்களுக்கு அந்த comments சொன்ன project operations where I'm going to specifically take the entire row or again I'm going to specifically complete entire attributes, right? So here I'll be having an syntax select expressions from table. From a table will be a from will be a keyboard. A table will be again you want to specify table name where some conditions. For example, if you want to search, if you want to select an employee name from the employee table, and then with the conditions of age will be greater than 20, then it should be specified in a query language as below. Like select emp name. Like this particular name will be an attribute which I had specified during a creation process. So it should get reflected as such. From again it is a keyword and I'm going to specify in the table name where is a keyword and I'm going to specify conditions. Okay, so in this condition, if this condition gets matched in a table of employee, the employee name alone will get displayed. So this is up to your query language. So I think this is up to your SQL commands. So SQL commands we do have your DDL, DML, DCL, TCL, and DQL. Okay. So in terms of a DDL, we'll have create, drop, alter, and truncate. DML will have insert, update, and delete. And DCL will have grant and revoke. And TCL will have commit, rollback, and save point. And DQL will have your select command. Okay, so this is up here. SQL commands. Now I move on to the same SQL commands along with the constraints, integrity constraints. Huh? Yes, are you there? No response. Anyway, I'll move on to the next topic. Integrity constraints. It is not much. We'll have only 2 to 3 slides. in the constraints. Let's see the first alone, integrity constraints. So integrity constraints is nothing but these are the rules enforced on the data columns of a table. So the constraint should be either on a column level or on a table level. So constraints in the sense will have some certain restrictions or certain rules to be enforced on a data column of a table. So either the constraints can be applicable either in a column level or in a table level. Okay. So the column level constraints are applied only to one column, whereas the table level constraints will be applied to the whole table. Yes, of course. So the column level அப்படிங்கிறது when I'm giving one particular restrictions or one particular rule to a column, that should be applicable only those only attribute, not for the entire table. Whereas when I'm specifying the same constraints in terms of a table, then that constraint will be replicated or will be reflected only the entire table alone. Okay, now through which way, through what are the commands we do have for an applying constraints in the sense can be specified when the table is created with the create table, or we can use an alter table statement to create constraints even after the table is created. Okay, so we can done in terms of two categorizations, one during a creating a table, another we can do in terms of an alterations after suppose நான் create பண்ணிட்டேன் அதுக்கப்புறம் நான் வந்து சில constraints add பண்ணணும்னு நினைச்சேன்னா that can be done with the help of an alter table. Okay. Now, what are the constraints available? Abdina, not null constraint, default constraint, unique, primary, foreign key, check constraints, and index. Okay. So coming to a not null constraint. So this ensures that the column cannot have a null value. So not null in the sense it is similar to one not only similar to a primary key, mean that it should not have a null value. It should have an some value within that. Okay, primary key அப்படிங்கும்போது it should have a unique value. So now moving to constraints in an SQL, we do have a not null constraints, default constraint, unique constraint, primary key, foreign key, check constraint, and index. So what's the difference between a not null and primary key is nothing but not null in the sense we should have each and ensures that each and every column must have some value. It should not have any null value, mean that it should not be blank at all. Okay, but we are not specifying that it should be unique, but only the condition is it should hold some value. Okay, that is up to a not null constraint. One second. Now moving to the second one, default constraint. So default constraint provides a default value for a column when none is specified. Suppose if I'm not giving like this is I had discussed with an insert command. Insert commandல நீங்க எத்தனை columns நீங்க specify பண்றீங்களோ எல்லா columnக்கும் நீங்க வந்து values insert பண்ணும்போது டிஃபால்ட்டா நீங்க வேல்யூ ஸ்பெசிஃபை பண்ணணும். சப்போஸ் அந்த இடத்துல ஏதாவது நான் மிஸ் பண்றேன் அப்படின்னா அந்த இடத்துல டிஃபால்ட் கன்ஸ்டன்ஸ் நான் அப்ளை பண்ணியிருக்கேன்னா ஆட்டோமேட்டிக்கலி வில் டேக் தட் பர்டிகுலர் வேல்யூ அந்த வேல்யூவும் எடுத்துக்கும். அப்ப எனக்கு எரர் வராது. ஓகேவா? there is unique constraint is nothing but ensures all the values in the column are different. Nothing but unique in the sense it should not have an redundant values like duplicate values allow பண்ணாது. ஓகேவா? And what is primary? This is the most important one in constraint in an SQL. So primary key, it uniquely identifies each row and record in a database table. When I'm specifying a particular attribute, a particular column will be a primary key, then that should be an identification for the entire row or else entire record in a database table. Okay, say suppose when I'm taking a student table and example, so definitely I should have a register number as a unique values, right? So there I'm going to take unique register number as a primary key, which represents an unique identification for the entire databases. Okay, ma'am. And foreign key represents unique identification between a row in any of the given database table. When I'm going to have an apply this foreign key, which represents an unique representation between the tables. Okay, ma'am. And check constraint in the sense, so this we can apply in terms of a column like a phone number or email, where I'm going to check that. For example, even I'm going to enter some age value for a particular field of age. Again, I can have some restrictions, like it should be within the value of like 35 to 45. So on the restrictions check constraints நம்ம specify பண்ணிக்கலாம். That is up to a check constraint. And index, it is used to create and retrieve the data from the databases very easily. This is nothing but normal index, a table of content, similar to that. There I can able to have an indexing. From there I can access the databases in an easiest way. Like accessing time எனக்கு வந்து reduce ஆகும். These are some of your constraints we'll be having here. Commands. So some example. So create table name. We had created this one. இது வந்து either எனக்கு வந்துட்டு table create பண்ணும்போது எனக்கு create table name கொடுத்திருக்கேன், and then we had specified a field name followed by a database like data type specify பண்ணிருக்கேன். At last I'm going to specify which is going to be a primary key. இது வந்து primary key identification, primary key constraints. Either I can do with this help of creation, or I can do with the help of your say suppose நான் ஆல்ரெடி கிரியேட் பண்ணிட்டேன், அதுல நான் என்னோட ஒரு பர்டிகுலர் காலம் நான் வந்து பிரைமரி கீ ஆட் பண்ணணும் அப்படின்னா that can be done with the help of an alter table customer. Say suppose add, we should specify a keyword of add and then primary key of which particular attribute. Okay, அதை நீங்க specify பண்ணணும். ஓகேவா? So this is up to one SQL constraints. Okay. So maximum நம்ம constraints apply பண்றது வந்து primary key நம்ம கொடுப்போம். Foreign key எப்ப நம்ம கொடுப்போம் அப்படின்னா join queries apply பண்ணும்போது. வேற check constraints என்னோட default constraint, not constraints எல்லாம் வந்துட்டு நம்ம query creations அப்போ நம்ம வந்துட்டு எந்த particular fieldக்கு வந்து இந்த conditions match ஆகணும், like எந்த particular field வந்து கண்டிப்பா values hold ஆகணும், null value இருக்கக்கூடாது, அந்த மாதிரி constraints எல்லாம் வந்து நம்ம create table மூலமா நம்ம பண்ணிக்கலாம். ஓகேவா? This is not only during a creations. Say suppose if I created already, then I can also do with the help of an alteration again. எனக்கு alter command யூஸ் பண்ணி நான் வந்து modify பண்ணிக்கலாம். Okay, but this is up to one constraints. Now moving to normal forms. I think you are well aware with the normal forms. So normalization, why we go for a normalization? Normalization na enna first? So why we go for a normalization? Any idea? So why we go for a normalization? Pa? So we'll have some of your following characteristics. Like normalization in the sense we are going to divide a table into meaningful divisions. Like again, we are going to divide it into further sub tables, but it should be in meaningful formation. So what are the characteristics that I'm going to consider in the sense? One, in terms of scalar values in each and every field, and then absence of redundancy, minimal use of null values, minimal loss of information. Okay, once I'm going to divide a table, like entire large table, into some smaller subdivisions of a table in the sense, definitely we should avoid a redundancy, and then it should not have a loss of information there, and then at the same time it should minimal use of null values too. Okay, so by considering all these categorizations, we are going to have a normalization process, right? So these are the levels of normalizations. Like based on the amount of redundancy in the databases, the normalizations can be divided into these categorizations: one, two, three, and then four, boys code normal form. Then we'll be coming to a fourth, fifth, and then last one is a domain key normal form. Okay, maximum நம்ம வந்துட்டு third normal form ஓட தான் maximum நம்ம யூஸ் பண்ணது, not more than that. Okay, sometimes we'll go with the boys code, but maximum first, second, and third normal forms தான் நம்ம யூஸ் பண்ணிருக்கோம். Okay, now so this is second and so this shows your levels of normalizations. We'll start with the first normal form. Each and every higher level is a subset of a lower level. So definitely when I'm taking a first normal form, so second normal formல இருக்கும்போது கண்டிப்பா என்னோட ஃபார்மட் நான் கன்வர்ஷன்ஸ் வந்து ஃபர்ஸ்ட் நார்மல் ஃபார்ம்ல டிஃபால்ட்டா இருக்கணும் அண்ட் அப்ளை டு அன் சப்ஜெக்ட் டு தி செகண்ட் நார்மல் ஃபார்ம் கண்டிஷன். That is again a default subset. We are going to take it in forward to one next level of normal normalizations. Okay. Now coming to your first normal form, a table will consider to be in a first normal form if all the fields contain only scalar values. So scalar values in the sense it should be like for example, scalar in the sense, I'll showcase the next example. So when I'm consider this is again a particular table like ISBN, title, author name, phone number, publications name, publication phone number, price. So here we can check with an author name as well as your author phone, like columns and scalar in the sense I should have only one particular value. ஒரு காலம்ல ஒரு ஃபீல்டுன்னு எடுத்துக்கிட்டோம்னா ஒரு வேல்யூஸ் மட்டும் தான் இருக்கும். இப்போ ஆத்தர் நேம் கேன் பி ஸ்பிளிட்டட் இன்டு டூ, லைக் மூணு நேம்ஸ் இருக்கு இல்லையா? ஸோ அதை நம்ம என்ன பண்ணணும்னா அது ஸ்கேலாரா இல்லை அப்படின்னு நம்ம சொல்லுவோம். தட் இஸ் அகேன் இட் இஸ் நாட் இன் ஃபர்ஸ்ட் நார்மல் ஃபார்ம். ஹென்ஸ் வி ஆர் கோயிங் டு ஃபர்தர் சப்டிவைடட் இன்டு ஃபார்மேஷன்ஸ் லைக் அந்த பர்டிகுலர் கேட்டகரைசேஷன்ஸை மட்டும் நம்ம வந்து சக்ரிகேட் பண்ண போறோம் டேபிளா. ஓகேவா? ஸோ பிளேஸ் ஆல் தோஸ் ஐட்டம்ஸ் தட் அப்பியர் இன் த ரிப்பீட்டிங் குரூப் இன் நியூ டேபிள். ஸோ எதெல்லாம் உங்களுக்கு வந்து ஸ்கேலார் வேல்யூஸா ரிஃப்ளெக்ட் ஆகாம இருக்கோ அதை மட்டும் நம்ம செப்பரேட் பண்ண போறோம். பட் டெஃபினெட்லி எனக்கு one common primary key should be reflected to each tables, like that should be a primary key identification. So here I can choose your ISBN should be a primary key. So when I'm taking a first table, I can able to split the ISBN, title, publication name, phone number as well as price, and what are those data which is not in a scalar can be taken into a new table with the same primary key field. So primary field in the ISBN now again the same gets reflected here. Then I'm going to take the another two categorizations, like எந்தெல்லாம் வந்து multiple values இருக்கோ அதை வந்து நான் அடுத்த இன்னொரு டேபிள் கொண்டு வைக்கிறேன். Again the condition should not violate a first normal form. It should be in a single value தான் இருக்கணும். So here I can able to make that ISBN வந்து எனக்கு replicate ஆகும். ஓகேவா? So this is again I can do with the help of a first normal form. Now moving to your functional dependency. So functional dependency, why we going to have functional dependency na உங்களோட second normal form the functional dependency base பண்ணி தான் இருக்கும். If one of the set of attributes in a table determines another set of attributes in a table, then the second set of attribute is said to be functional dependent. Like functional dependent in the sense how we are going to, whether I'm going to have a complete functional dependency, like full functional dependency or partial functional dependency. Okay, for example, consider your example. We'll have a scheme like ISBN, title, and as well as price. Here, எதெல்லாம் வந்து டிபெண்டன்சி அப்படின்னு பாத்தீங்கன்னா டெஃபினெட்லி எனக்கு ஐஎஸ்பிஎன் தெரிஞ்சிச்சுன்னா கண்டிப்பா டைட்டில் வேணும். அண்ட் ஒன்ஸ் ஐ நோ யர் ஐஎஸ்பிஎன் ஐ கேன் ஏபிள் டு கெட் தி ப்ரைசஸ் இல்லையா? So these are two functional dependencies, like most dependent one. ஒரு particular value எதை depend பண்ணி இருக்கணும் அப்படிங்கிறத அந்த dependency பொறுத்து we are going to take it. That is an tabulations. Okay. So this is how we'll have your example. Now moving to your second normal form. Okay. So second normal form அப்படிங்கிறது for a table to be in a second normal form, there are two requirements. So this is again now this is highest subset, highest level போக போக இன்னொன்று இது subset தான் இருக்குமே தவிர not at the entire complete second normal form also. So here in the sense, for a table to be in a second normal form, there should be two conditions. First one is it should be definitely in a first normal form, and the second category is that all non-key attributes in a table must be functionally dependent on the entire primary key. So when I'm specifying a primary key, definitely all other non-attributes in a particular table must be fully functional dependent. Okay, that is the in how the conditions, matching those conditions only I'm going to segregate the tables. Okay, now I'll take an example. Just consider an example here. We'll have a new already existing table as title, a publication ID, author ID, price, and author address, right? So how we can able to segregate this based upon a functional dependency in this attributes which is dependent to each other, that gets segregated, right? When I'm taking a title and then publication ID, author ID as well as price, these are related to each other, right? So hence this will be taken into one new table, and in another table I can take this your author ID as well as your author price. So in both the tables, your author ID will be acting as a primary key, and then with the help of those primary key, I can able to reflect both the tables like first table as well as the second table. Okay, first table once I'll come to an author ID, there I can able to take the title, the publication ID as well as the price. With the same case, when I'm taking the second table with the help of same author ID, I can able to represent their addresses. Like that is not fully functional dependency, hence we'll be segregating that into second databases. Okay, this is up to your second normal form. Similarly, we'll have another example: studio, movie, budget, and studio city. Here, your movie, studio, and budget will be dependent to each other, and then the studio as well as the city will be taken into a new table. Okay, ma'am. Similarly, we'll have another example also: city, street, house number, house color, city populations. So here I can able to take the fully functional dependency as city, street, house number, and house color will be in one form, one tabulations. And another thing, I'll be taking a city as well as a city population will be taking into next one. Okay, ma'am. Now, moving to third normal form. So this dictates that all non-key attributes of a table must be functionally dependent on a candidate key. That is, there can be no interdependencies among non-key attributes. Like A to B, B to C, and the formations எனக்கு இருக்கக்கூடாது. The interdependency இல்லாம எனக்கு வந்து ஒரு functionality depend ஆகணும். Okay, for example, if a table should be in a third normal form, then the two requirements should be as like the previous one. The table should be in a second normal form, and no attribute is transitively dependent on the primary key. As I had said that A to B, B to C, and the conversions and the dependency இருக்கக்கூடாது. Okay, so it should avoid a transitively dependent here. So this is some example which is not in the third normal form. We'll take title, publication ID, page count, and price. So here the transitive dependency அப்படிங்கிறது வந்துட்டு third normal formல இருக்கணும் அப்படின்னா கண்டிப்பா வந்துட்டு it should not have any attribute in a transitive dependency, right? Now I'll showcase another example. Now we'll take again டைட்டில், பப்ளிகேஷன் ஐடி, பேஜ் கவுண்ட் அண்ட் பிரைஸ். ஸோ இதுல என்னென்ன கண்டிஷன்ஸ் என்ன அப்படின்னா, உங்களுக்கு கண்டிப்பா செகண்ட் நார்மல் ஃபார்மாவும் இருக்கணும், ஃபங்க்ஷனல் டிபெண்டன்சியாவும் இருக்கணும், பட் இட் ஷுட் அவாய்ட் a transitive dependency also. ஓகேவா? So how we can convert this into an table right here is, we'll take your publication ID, page count and price in one particular table, and similarly உங்களோட publication ID, title and page count will be in another thing. ஓகேவா? So keeping that condition set, it should have a functional dependency as well as here transitive dependency இல்லாம இருக்கணும். That is how the condition should be in a third normal form. Here I will be giving, this is again a decomposition stage. Okay, ma. These are the other two examples. Like the same, studio city, and city temp will be taken into considerations for a third normal form. So fully functional dependency of Digma, contribute studio and studio city, and we can take the studio city as well as the city temp into another table. Okay, so this is up to one third normal form. Now coming to the next one is a boys code normal form. I think up to a third normal form will be utilizing in your maximum usage. Maximum usage of your normal form is a first, second, and third, and moving to a boys code normal form, that is BCNF. This does not allow a dependency between attributes that belong to a candidate key. So moving to the next normal form is a Boyce code normal form. Does not allow dependencies between attributes that belong to a candidate key. Nothing but it is a refinement of a third normal form in which it drops the restriction of non-key attribute from a third normal form. Mean that maximum it should be an one and the same. Only the because of the following conditions alone will get different. So what is the difference between third normal form as well as a Boyce code normal form in the sense the table has two or more candidate keys, and then second condition, at least two of the candidate key are composed of more than one attribute, and the keys are not disjoint. That is the code normal form. So place the two candidate primary keys in a separate entity, and suppose each of the remaining data items in one of the resulting entities according to its dependency on the primary key. Okay, ma'am. Now converting this into a Boyce code normal form. So this is again an example of a Boyce code normal form. So consider a scheme which is having an attribute of city, street, zip code. Now this can be converted into a functional dependency, as well as we should not have your transitive dependency format. Hence, we can able to convert into two tables: one in terms of zip code as well as street. Another table would be in a city and street. What happened here is we'll have a loss of relationship between a zip code as well as city, right? So once I'm having a zip code, I couldn't able to identify the street, and then city and street nalume, there'll be again a loss of relationship. So what we can say is we can take an alternative scheme like we'll take a zip code and street as well as zip code and then city. This is again a new barcode for normal form. This is again a new conversion. Then now I can able to communicate like this particular zip code will have this particular street. Again, the same zip code in the particular city and easier references. So this is again an example of a barcode normal form. Now, so again, why I'm specifying here is a loss of information in the sense. So while converting a tabulation into again dividing into further subdivisions based on a Boyce code normal form, definitely எனக்கு வந்துட்டு அங்க you should not have loss of information. Okay, so again we'll have your lossless decomposition must be taken considerations in here. At the same time, this decomposition does not cause any dependencies to be lost. It is called a dependency preserving decomposition. Like with that, we should not lose any particular information. Lossless decomposition and then that those lossless decomposition is said to be a dependency preserving decompositions. Okay. So always when the third normal form compare we'll go ahead always with the Boyce code normal form. So coming to a fourth normal form, this eliminates any independent many-to-one relationship between the columns. So what I'm going to avoid in a fourth normal form is here many-to-one relationship can be avoided. For example, we'll take an example here. Many-to-one in the sense we'll take a movie name of hardcode. This will be screening city when the both Los Angeles, New York. So in the multiple number of many-to-one relationship should be avoided in terms of fourth normal form. We'll take an example. So while taking a fourth normal form decomposition, that we need to take two things in considerations. First one, it should move the two multi-valued relationship in a separate table and identify a primary key for each of the new entity. So for example, again the same example, movie name, screening city, and genre can generations like whether it is a comedy, drama, horror movie. General category. So here I can able to convert into two categories. So I can take movie name as well as screening city in one particular table, another table movie name as well as a gender. Okay. So here I can able to replicate your multi-valued aspect attribute can be separated. At the same time, we can take your primary key in both of the tables. Okay, this is up to one fourth normal for decompositions. This is some of another examples taking a manager, child, and employee. So in terms of manager, child, and employee, I'll take manager and child in one particular table and manager as well as employee in another table. And moving to the next example, employee skill foreign languages. Employee will be keeping as a primary key, making skill as another attribute, and foreign language will be another attribute in a separate table. And fifth normal form, it is satisfied when all the tables are broken into as many tables as possible in order to avoid redundancy. Once it is in fifth normal form, it cannot be broken into smaller relations without changing the facts or the meaning. So only the thing is how much number of possibilities we do have for a particular divisions, we can go ahead with in terms of fifth normal form. Only the cases we should not have a loss of information. Like the meaning as well as the fact should not be changed unless otherwise I can able to go ahead with the fifth normal form. Whatever may be the number of tables, possibilities, maximum possibility can be taken into a fifth normal form. Okay, that is up to one. Fifth one, and coming to the last one is a domain key normal form. So whenever I'm saying that relationship is in a domain key normal form, when there can be no insertion or deletion anomalies in the databases. So when I can say domain key normal form of anomalies in the sense like replications, like duplications, both as well as insertion as well as deletions in the end manipulation process name in a anomalies avoid ஆகுது அப்படின்னா I can say that the given relationship is in a domain key normal form. Okay. So this is up to your database normalizations. I think we had covered the first half portions, like what has been an ER model, basic introduction about a database management system, and then disadvantages of file processing system, and relational model, relational algebra, tuple calculuses, SQL, integrity constraints, and coming to normal forms. So in next class, we are going to see about a file organization, indexing, like only the B and B plus, like we'll have index table, hash table, everything. Like specifically, we're going to learn about B and B plus tree, transactions, and especially concurrency control. So this will be from file organization till your concurrency control. We are going to learn from the next class. Okay. So now we'll just go ahead with the PPT. So far, what we have discussed. I'll take back the same normalization example alone. Just go ahead, ma. Go go through your slides, ma. Let's say gate questions will fall under this normalization. Huh? Harmonization and SQL, like under integrity constraints. Okay. I think no one is listening. Damn sure. Can refer a previous gate questions, ma. Next class, I will showcase your questions which is belongs to your DBMS questions alone, like gate question. Okay, I'll take those questions and we will discuss in our next class. I think next class will be on 4th. I think so. So we'll take the gate questions to discuss more. Any other doubt, ma, so far? I think I'm having only 3 students here. Guys, In this PPT, I have taken example which is respected to the concerned normal form and which is not in the formats also. Okay, more than 3 to 4 examples which showcases your example which is in a third normal form and how we are going to convert that into a normal formations. Okay, and similarly for the voice code normal form also, you can able to identify the differentiations between the tabulations like schemas which is not in a BCNF and then which is in a BCNF. Okay. So the same, how we are going to convert into a BCNFs, we should have an lossless information, like it should be dependent, like decomposition preserving law. Okay, ma? So these are the examples where we had seen previously, which is not in a BCNF. Now we can have a comparative status with the BCNF format. Okay. So coming to a fourth normal form again, the scalar values. It should not have many to one relationships. So if I'm having more than many to one relationship, that alone get be separated to the next table. So for example, screening city will have more number of cities for the same movie. So that in case I can able to segregate the same movie name as well as the screening city written into another table. Okay. So you can see to that the same example converting into three name. And similarly, for the next example, a manager child employee as well as employee skilled foreign languages, the same gets reflected. If I'm having more number of many to one relationship, then that alone will be decomposed, like that alone be taken into a separate table, separate scheme. Okay. So fifth normal form is nothing but an example where we can able to broke the number of tables, like broke the tables into as many as tables as possibility. But the main condition, the constraint here to be taken is we should not change the facts as well as the meaning. Then is it possible to convert into an entire number of tables? Okay, so there is no restrictions. There is no constraints to be followed. Only the condition is we can able to convert into maximum possibilities of tables. Okay, this is a perfect normal form. And domain number key, we should, if suppose if there is no insertion or deletion or models in a table, then the particular relationship is said to be a domain key normal form. Okay. So I think I covered with your normal forms. Okay. So from next class, we are going to learn about your file organization, indexing, transactions, and concurrency control in depth. Okay, and followed by some gate coaching, gate question papers, previous year question papers also, which belongs to a database management system. Also, we will discuss that too again. Okay. Okay, ma. Okay, but thank you. Pa. We'll meet you on next class.